Hey guys, and welcome back. In today's video, we are going to be evaluating trig functions using function notation. So in the last class, we learned how to evaluate three brand new trig functions or reciprocal functions. And today we're just going to be practicing evaluating them, but using function notation, which oftentimes is the ones that students look at and get scared of and terrified of. So let's hop into it and practice evaluating these trig functions with function notation. Okay, so what we're going to want to do first is to evaluate the function f of x for the following. So it gives you a function f of x, it gives you the definition, it's just sine of x, and then it's listed f of 0, f of pi over 2, f of pi, f of 3 pi over 2, and f of 2 pi. So essentially, when you're evaluating a function, what we're really doing, if we look at the root word of evaluate, right, we're trying to find the value of a function at a specific x value. We're trying to find the value of a function at specific x values. And if you remember from function notation, like x is an input, y is an output. So we're really just seeing if we plug in different inputs, what is the output? If we plug in different x values, what is the y? And we're really just finding the height of our function at those particular spots. So let's hop in and check it out. So our first function that we're working with is sine of x, and f of 0 means that we're just going to plug in sine of 0. Oops, that's a little messy. Sine of 0, right? So I want to figure out what is sine of 0, and I really just need to go back to my unit circle, right? This is 0 and 2 pi. So looking at this coordinate right here, what is sine of 0? And that coordinate is 1, 0. And remember, xy becomes cosine, sine. So sine evaluated at 0 is just 0, since that's the y coordinate. Moving on to f of pi over 2, we're going to just plug in pi over 2 to x. So we're going to figure out what is the value of sine when x is pi over 2. Now, again, we're going to have to remember that if over here at our unit circle, if this is 0 and 2 pi, halfway across is pi, and then halfway between 0 and pi is pi over 2. And that coordinate right there is x is 1, y is 0. Oops, I lied. JK, making sure you guys are paying attention. Actually, x is 0, y is 1, right? So if I want to find sine of pi over 2, that means it's just going to be 1 because the y coordinate or sine is 1. Moving on, pi is going to give us, f of pi is going to give us sine evaluated at pi. Again, pi is all the way over here on the unit circle. That point is x is -1, y is 0. Remember, it's cosine, sine. So sine of pi is going to be equal to 0 because that y coordinate is 0. F of 3 pi over 2 just means sine evaluated at 3 pi over 2, or the output when sine is 3 pi over 2. Right down here at the bottom is 3 pi over 2, and that coordinate is 0, -1. So sine of 3 pi over 2 is the y coordinate, -1. And lastly, we have f of 2 pi, which brings us literally full circle. So sine of 2 pi, we've actually already done that because 0 pi is the same thing as 2 pi. We're just going around our unit circle one entire rotation. So x is 1, y is 0. Sine of 2 pi is 0. Okay, let's work with a different function then. So evaluate g of x for the following function. G of x is equal to cosecant x, and we have 0, pi over 2 pi, 3 pi over 2, and 2 pi again. And sometimes they'll be listed out like this. Sometimes it will just say evaluate for the following and kind of write something along the lines of x is equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. Sometimes they'll just list them out. Sometimes they will give you g of 0, g of pi over 2, all of those things. Sometimes they'll make a table. Oops. Sometimes they'll make a table and say x is 0, pi over 2, pi, 3 pi over 2, 2 pi. It just really depends. So let's jump right in. G of 0 is then going to be cosecant of 0. Again, go back to our unit circle. Right over here is 1, 0. This coordinate over here is 0, 1. This coordinate over here at pi is x is -1, but y is 0. This coordinate at 3 pi over 2 is x is 0, but y is -1. So remember, cosecant, though, is going to be 1 over sine evaluated at 0, since they're reciprocals. And sine of 0 is just 0. But we can never, ever, ever divide by 0, so this is actually undefined. Never, ever, ever divide by 0. And then we just continue the pattern. So go ahead and evaluate pi over 2, g of pi over 2. That's going to give us cosecant of pi over 2, which gives us 1 over sine of pi over 2. And pi over 2 is right up here. 1 over 1 just gives us 1. G of pi is going to be cosecant evaluated at pi, which means cosecant and sine are reciprocal. So it's going to be 1 over sine of pi. At pi way over here, y is 0. So we're going to have 1 over 0, which we never, ever, 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 ever deal with. We don't say that it's just 1 over 0, though. We go further. We know better at this point. This is undefined. G of 3 pi over 2 is going to give us cosecant of 3 pi over 2. But cosecant is reciprocal of sine. So it's really 1 over sine of 3 pi over 2. And sine at 3 pi over 2 is -1. So I have 1 divided by -1. Luckily, 1 divided by -1 just gives us -1. And lastly, g of 2 pi is cosecant of 2 pi, which really means 1 over sine of 2 pi. And we've already discussed sine of 0 pi and 2 pi. They're the same thing, just one's 0 rotations around. 2 pi is 1 entire rotation around. So we end up with 1 divided by 0, which again is undefined. Now, what's happening where we get these undefined things? With our graph of cosecant, we actually end up with vertical asymptotes. We won't get into the graphs. You guys will see more of that in pre-calculus. But know that something does happen when we have our undefined regions. There are asymptotes there, which is why we can't divide by 0. It's why we can't graph anything, it's actually a pretty interesting graph. So you'll see that in the future. Let's do some more. All right, what about cosine? Good old cosine. I want you guys, now that you've seen sine and cosecant, I want you guys to go ahead and evaluate h of 0, h of pi over 2, h of pi, h of 3 pi over 2, and h of 2 pi. Be sure to draw a little draft of your unit circle, at least the 4 quadrantal points, like I'm doing over here on the right. It really helps to visualize and list out the points. Remember, the radius is always equal to 1 in the unit circle, hence the fact that it's called a unit circle. And I'll see you in just a sec.